Welcome back. This is Factoring by Nick I. Graham. I will be discussing perfect square trinomial. So I will write here perfect square trinomial. Okay, but I will remind you that when we have this, x plus y squared, I think I did with a plus b, but it doesn't matter. The product of this is x squared plus 2xy plus y squared. And if the difference of two terms, the square, and we square them, we have x squared minus 2xy plus y squared. The left hand side are the products, as you can see. These are the products. And these are the factors. So if we have perfect square trinomial, then the factors should look like this. Okay? We'll take some example. I think that I will start writing example 1, example 2, so that you will not be confused. 4a squared plus 12a plus 9. How could I know, or how could you know that this is a perfect square trinomial? You need to do some investigation. I need to investigate. Where is my pen now? Okay, there is my pen. I need to investigate if 4 is a perfect square. Yes. 9 is a perfect square. Good. So, can I have a product 12 as 2 times 4 and 2 times 3? Is that a product? Is that a 12? The factor of 12 is 2 times 3. That's 12. Yes. How could I use 2 and 3? The factor of 4 is 2 and 2. And the factor of 9 is 3 and 3. Then I should get the first term, as you can see here, and the last term. So the first term is 2. And then the last term is 3. And then we have the a there also. Sorry, I forgot to put 2a. So we have 2a there. Then it is 12a. Then, if you are finished with the investigation, then you have to put them in a parenthesis. We have 2a plus 3, because it's plus here. If this is minus, then it should be square. You can multiply that so that you can see if you've done right. Okay. Second example. And we have n squared plus 16n plus 64. First question, are these perfect squares? The answer is yes. 8 times 8. This one is n times n. 16 is 2 times 8 times n, 16n. Good. Then I am finished with that. I will put them in parentheses and then square them. We have n, just one of them, plus 8. And I'm finished with that. Let's take a look for another example. We have 49g squared minus 84g plus 36. Are these perfect square? Yes. 49 is 7 times 7. So we have 7g. 36 is 6 times 6. 84. Can I have 84 as a product of negative 2 times the first term, 7g, times 6? Is that 84? 14 times 6. Times 6, we have 4. Yes, it is 84. Then I have the first term is 7g minus 36 is 6. Sorry. 6 square. 4. I'm going to look for this one. Oh, this one is good. 20 f raised to 4 minus 60 f raised to 3 minus plus 45 f squared. My question is, are these perfect squares? No, but maybe later. So if, as you can see, there is a common factor, there is f squared there, there is f squared there, there is f squared there. So I need to put out f squared. Okay? And then 20 is 5 and 4. 60 is 15 and 4. And 45 is 9 and 5. So I should have 5 and 3 here also. Okay, then I have 5 also. Then I will put that outside. The remains here now is 4f squared, as you can see. 4f squared. I will put f squared there. Then we remove 5f squared. Then we have only 4f squared. Minus, we have 12, as you can see here. I remove 5. Then we have 3 times 4 is 12. And I remove f squared. Then we only have f. And we have 9 without f. We remove f already. Then we have 5f squared. Our question now is this a perfect square? I think the answer is yes, because 4 is a perfect square, 9 is a perfect square, 12 is negative 2 times 4 times 3. Yes, so we have 2f. This is 2f, 2f minus 3 squared. Try to multiply them so that you, if you get the same product as this one, then we have done right. Always do that when you're doing your factoring, at least in the start of your learning factoring perfect trinomial. I hope you learned something from this video, and we'll see you soon. I will just look for the next topic. Sorry for the sound again. What is the next topic? The next topic will be general trinomial. It's a little more difficult. There is no rule that we can follow, or yes there is, but we'll see. See you then.